Hi everyone. In today's short video, I'll be talking about past exam 2019 question 40, which is about critical path analysis. You can find this question on our website studyninja.com.au, where all the chapters related to HSC standard maths and the questions are sorted by chapter. So this one is under critical path and exam questions. So 2019 question 40. And to solve this question, all the skills that you need to know are under 19.1, 19.2, and 19.3. Most importantly, this one, maximum flow and minimum cut theorem, which it explains in detail what it's about through example and solution as well. So let's go into the question. Let's take that question out, which is this one. Now, there are two parts of this question. Let's focus on the first one. The first one is saying there is a museum manager, and this is a plot of a museum where each of the edge is showing the capacity that it can hold. And each of the vertex is a room in this museum. The first question is pretty straightforward. All they want to know is the capacity of a cut. This is the cut that they have drawn, and what they want to know is what is the capacity. So let's zoom into this. Let's take this thing out. There are a few things you need to understand. Firstly, let me take my pen out. Okay. Firstly, whenever there is a cut like this, you only consider those edges that have the entry on the left side of the cut and the exit on the right side of the cut. Only consider those. If you do that, your life would be easy. So let's do this. So on this cut, the first edge is AD. So AD starts from the left side. The entry is on the left side of the cut, and the exit is on the right side of the cut, which means this is okay. This is okay. We can consider this. So we will use AD is equal to 70. Okay. Next is AC. Again, left side is entry, right side is exit, which is okay. So we'll use AC is equal to 90. Third one, BC. Notice this is different to these two, where it's starting from right side of the cut and ending on the left side. So the exit is on the right side and the entry is on the left side, so we're not going to consider this. Last one is PE, which fulfills the criteria, so you will consider this PE, and this one is 130. So the total capacity would be 70 plus 90 plus 130, which is equal to 290. So that's good and easy. Let's move on to the second question, part B. Now the part B is saying that the museum manager is planning for a maximum of 240 visitors to pass through. So if you see in the entry, they wanted 240 visitors. But what he's saying is that by using the minimum cut and maximum flow theorem, first determine that what he wants is not achievable. And I'll show you how to do that. Once you do that, then comes the second part of the question, that what it's asking is how is it achievable? How we can make sure that 240 people pass. But before answering that, we need to first prove that 240 people cannot pass. So let's come to this diagram. Okay. So first thing you need to do is you need to determine what is the flow in each of these edge. This is the capacity 90, but it's not necessarily that all 90 people can pass, and I'll show this to you. So let me choose some different colors for my pen. Let's start with red. So let's say starting off 80 people come through Then on the second edge AC, let's use yellow color here. Let's say 90 people go through, and then the last one is all 70 people come through. Okay, so 70 plus 80, 150, 150 plus 90, 240. So all 240 people go through, for example. Now let's move on. Let's say all of these 80 people, start from here, all of these 80 people flow through BE. So let me change my ink again. So all 80 pass through. Then for this one, let's say 65 go, let's say 65 go through CE. Now out of 90, what is remaining? 90 minus 65 is 25, right? 25. So the remaining 25 will go here. Okay, that makes up 90. So it's all good up until now. Come to the remaining 70. Now with the remaining 70, let's say these 45 pass through here. Okay, 45 go through. How many are remaining after 45 go through? So 25 are remaining, right? So if 25 pass through here, there would be a problem, because if the 25 pass through, no one can go here because this is all utilized. 65 is all utilized. The most C to B can take is another 15. So only 15 can go here. Okay, which means that this one would only be 15, which means that AD can only take 45 plus 15, 60. So we need to change that. So let's erase this bit and let's change it back to 60. Okay, now what that means is that at any point 80 plus 90, 170 plus 60, 230, only 230 people can come into this. So for a start, we have proven that 230 people can come into this. But since we are on this, let's just complete the whole diagram and we will come back to the second part of the question, what to do about it. So let me just complete this further. So you've got 40 over here. Now these 80 came from here. Only another 40 can come here, right? So you will have another 40. So what that means is, let me change ink and make it a more hard-coded number. Okay. So that means the final capacity here would be 120. Okay, 120 plus 65 plus 45, right? 65 plus 45 is 110, and 110 plus 120 is equal to 230. So 230 can exit, 80 plus 90 plus 60, 230 can enter. So this is the problem. So with this diagram, we have shown that only 230 can be in this museum at any point. Now comes the next part. So what they're asking you to do is draw the minimum cut and then recommend a change to the manager to one or more security points to increase the flow capacity to 240. What he wants is 240 people. So, and then they want you to draw as a minimum cut. And what's the relationship between these two? I can explain. Just a minute. Let's draw the minimum cut first. So the minimum cut would be, minimum cut you can draw from any place, any of the edges, that add up to the total, which is 230 here, and that are saturated edges. By saturated edge, I mean 70 has, for example, AD is not saturated. There is a 70 capacity of 70, but only 60 is being used up, so it's not saturated. So you shouldn't cut through this edge. You should cut through this one. This one's okay. AB, 80, 80. This one's okay. 40, 80 plus 40 is 120. 120 plus 65. This is also saturated, which is 185, and then plus 45, which is 230. So we will cut through like this. Okay. So this is the minimum cut. What can be done? You can increase the capacity of any of these edges and your problem will be solved. So the solution would be either you increase AB from 80 to 90, or you increase CB from 40 to 50, or you increase CE from 65 to 75, or DE from 45 to 55. Now, why do I say that? Let's actually take one example, which I think they talk in the solution as well. So CB, if we increase that from 40 to 50, what's that gonna do? If this number is 50, you know what that's gonna do? This 15 that can be taken now will become 25. Oops. Will become 25. That means this will become 25. That means this 60 will become 70. That means this 230 will become 240, 80, 90 plus 70. Okay. So why? So now your next, up until this point, you've answered the question. That's all what was needed to answer the question in the exam. Just for your further understanding, why did we need the minimum cut over here? Why can't we just cut anywhere? Why can't we just increase the capacity anywhere? Let me just undo what I just did. So let's go back to where we were. So get my pen and let's make this. This one was 60. So let's take this example. Say the manager has not done this minimum cut and he says, okay, let's increase the capacity of AD from 70 to 80. Okay, so let's say he makes it 80. What's that gonna do? And this is still 40. This is still 40, right? We don't change this. So if you're not increasing the capacity of the saturated edges, what that does is it does nothing to the overall picture. You make it 80, the problem is still here. 80 from here, 80 goes up here, 80 from 90, 65 goes here, 25 goes here, it's still okay, but this 15 is still going to be 15, which means this 25 can still only take 15, which means this, even if you make it 80, only 60 will still pass because 45 plus 15 is 60. So even if you make this 1000, that's not gonna make any more difference. So that's why the minimum cut is important. First, you need to determine that cut and then change any of the edges that are on that cut and increase the capacity. Hope this is helpful and I hope it explains. Thank you very much.